So let's talk a little bit about inheritance and type hierarchies in C#. So we will start with a Visual Studio project that's blank, and I add to this project a class called person. Now, by the way, I will be creating several classes as part of this demo, and I'm going to put them all in the same file just to keep things as simple as possible. So here's my class person. I'm going to add a method to this class, and that will write something out. Now you could imagine that I have a second class that's similar but not identical. And it also needs a method for saying hello. So of course, class person could have any number of properties, events, methods, what have you inside of it, and so could class cowboy. But let's just focus on one particular method. So as it is now, any member of person that I would also like to have inside of cowboy has to be replicated. And I want to avoid that replication. So what I can do is I can say that class cowboy is derived from or inherits from class person. Okay, so now what this means is that anything inside of person is automatically copied into cowboy. So let's consider a simple diagram. I have this base class person, and it is used to derive another class, cowboy. So that means that anything inside of person is automatically placed inside of cowboy. So this is the relationship of the two classes, but another way to think of this is like so. Any object of class cowboy contains inside of it an object of class person. So going back to the code, we notice that there's a green squiggle underneath say hello. And it says that say hello in cowboy is actually hiding a definition of say hello in person. And we want to keep that from happening. So what we're going to do is we're going to declare our method in such a way that that error does not take place. And what we do is we say that say hello inside of person is a virtual method. And in cowboy, we do a similar thing. We declare this as an override. So this is a good time to talk about the difference between override and overload. Let's imagine that inside of person, we had another method called say hello. But this one takes a parameter. Okay, so here we see an example of overloading. So overloading means that we have two methods in the same scope that have the same name but different signatures. Overriding means that we have a method in a base class and it has the same name and same signature in a derived class. But in order to do that successfully, we need to mark the base class's method with the keyword virtual and the derived class's method with the keyword override. So let's see what this looks like in main. I can create an object of class person and an object of class cowboy. And for each of these, I can call say hello. And for the person's version, we call the say hello that we saw in the person class. And for the cowboy version, we get the say hello that we saw associated with cowboy. So they're distinct. Of course, in this case, we only have one method in the derived class, but you could imagine there could be a lot of methods in person that cowboy also uses. For example, let's say everybody breathes the same way, we could go back to person and we could create a method. And it really makes no difference what the body of that method is. The point is that because we have this method breathe in person, it's also existing in Cowboy. So I could go back to the program and I could say p.breathe, and I could say c.breathe. So again, anything that's in person is automatically copied into Cowboy. If you want distinctive behavior based on the specific class you're talking about, then you make that method virtual, as we have here, in person, and you use the keyword override in the derived class. One of the easiest ways to see how this works is to have a data structure that contains both base class objects and derived class objects. So for example, I can have a person array, and I can set that equal to a new array of person, and give that the value new person and new Cowboy. Now I can iterate through that array and call that virtual method. And let's put a little mark on this so that we can see where we are in that code. Now, when we run the code, the important thing to see here is that when I called somebody dot say hello, and the actual somebody was a person, we got hello. But when I called somebody dot say hello, and the actual person was not just a person, but also a cowboy, I got howdy. So that's the power of virtual methods. The appropriate method is called even if the reference to the object is a base class reference. So in other words, I have a situation that looks like this. I have a reference of type person called somebody, and it points to an object that's actually a cowboy. So when I call say hello from this reference variable, I get the appropriate say hello for the object that I'm actually dealing with. And that's the power of virtual functions. Now there is actually another possibility, and that's known as the new keyword. So I could create another class, class spouse. It's also derived from person. So again, anything that's in person is automatically inside of spouse, or a spouse object contains a person object. But rather than creating an override this time, I could say public new void say hello. And again, this say hello would be distinct to the class spouse. So you remember before I got that green underline, and in fact this is what the new keyword is correcting. If I take that out, I once again get that same green underline. So new is saying this is not a virtual function, but I'm changing this class to have a specialized version of this particular method say hello. And then if we go back to our code where we're calling these objects, I can create a new spouse, and now when we run this code, we see that the first time it's dealing with a person, and so we get hello. The second time, even though we have a base class reference P, because of virtual functions, it calls the appropriate method. The third time, I'm pointing to a derived class spouse with a base class reference variable person, and because I've said that say hello is a new method, I don't get that virtual behavior. So essentially what the new keyword does associated with type hierarchies is it defeats the virtual function mechanism. So having said that, I'm showing you what new does, but it's pretty rare that you would actually use it. For the most part, when you're creating base classes, they're either regular methods, as we've seen all along, and they just simply get inherited into the derived classes, or they are virtual methods and they are overridden in the derived classes. To demonstrate how you would actually be able to use the appropriate method, even with the new keyword, we could do something like this. People sub2, which of course is the spouse, as spouse dot say hello. So in this case, we're specifically identifying a base class reference, or downcasting it, if you will, to be a spouse. And so now if we run the code, we will see that if you treat a spouse as a spouse instead of just as a person, you get that customized behavior which we created using the new keyword. Up until this point, we've completely replaced the behavior of the method that we're overriding. Let's consider the possibility that what you'd like to do is extend the behavior. So we'll create a new class here. Of course, it also derives from person. And now I will bring up the override list. So if we just type override into Visual Studio and hit the space bar, the one we want is say hello. And you will note that when Visual Studio suggests a definition for an overridden function, it will add the base keyword. And of course, in this case, base is person. So that is to say, that's the say hello method from the base class. And so what I'm going to do is extend the behavior of the base version of the say hello method by adding to it. So the other use of the base keyword is found in constructors. So let's consider the possibility that we have a field inside of our class person, and we would like to initialize that field inside of a constructor. So this constructor will require a parameter and note the use of the this keyword to differentiate between the field and the parameter, since they both share an identifier. Now that I've made this change, there's no longer a default constructor for the class person. So if we go back and look at our main code, we'll see that you can't construct a person this way, here or here. So for the purposes of the example, I will add a value at construction for person. Now going back to the hierarchy, let's assume that what I would like to do with cowboy or any of the other derived classes is also have that same sort of construction. So I might say something along these lines. So now I've got an issue. Person no longer has a parameterless constructor. So how do I call the constructor of person inside of cowboy? Because remember, inside of cowboy, there is a copy of person. And the answer is, again, the use of the base keyword. So in this case, after the name of the constructor, cowboy, I could say colon base and call the constructor associated with the base class, as you see here. Of course, spouse and party host have the same problem now. Since there is no default constructor, I have to figure out how to call it. So let's say, just for the purposes of the demonstration, that spouse needs to create the person. So that means I need to add similar constructors to the classes spouse and party host. Now a word about the field age. You'll note that I made the access specifier for age private, as we should in general make our fields private. Now that means that the field age is not available outside of class person, and that includes cowboy. So in other words, even if I wanted to, I couldn't say age equals some number, because age, being a private field inside of person, is not available outside of person, even for derived classes. However, it is possible to specify an access specifier of protected. And that means that this field is available inside of class person as well as any classes that derive from class person, which of course cowboy is one of those fields. And so now this initialization is legal. So that's what protected does. In more recent times, protected has fallen out of favor. And so you don't see it as often as you once did. And so now this is no longer legal, which means we have to use the base approach. What we had done up until this point was to construct a parameterless constructor for our derived classes, but maybe what we'd like to do is reflect the fact in our derived classes that our base class requires a parameter for its constructor. So rather than just putting an arbitrary number here, what I would typically do is include the parameter and then pass that parameter to the base class constructor using the base keyword. Of course, I would want to do that with all my constructors, most likely, or I could just do it with the cowboy constructor only. And then I would modify my main by including the number in that construction here. I would either have to add a parameterless constructor to cowboy or be sure to include something when I construct it. And so that's part one of inheritance and type hierarchies.